So in this video, we'll go over an AMC problem, which is the 2018 AMC 10B problem 23. So it's a pretty difficult problem. But, yeah, so before you watch this video, I recommend you to look at both the GCD and LCM videos in the number theory playlist, as it will require some techniques to do this problem. So the question says, how many ordered pairs AB of positive integers satisfy the equation a times b plus 63 equals 20 times the LCM of a and b plus 12 times the GCD of a and b, where GCD of a and b, well, you guys already know this, yeah. So first, let's say, so this equation looks really complicated, like how would you solve this? So first, let's put these values into variables so that things become easier. So first, let x equal represent the GCD of a and b, and let's say y represents the LCM of a and b. So first, one thing we need some conditions we have to put for x, and y when we solve this problem is that x must be smaller than y, because the GCD is a divisor of a and b, and the LCM is a multiple of a and b. So obviously the GCD is smaller than the LCM, and also x must divide y. And this is also obvious because the GCD is both a factor of a and b, and the LCM is a multiple of both a and b. So the GCD must be a factor of the LCM. So x must divide y. So we'll just remember these conditions later on when we're looking for the possible values of x and y. And what would a times b? How can a times b be represented as? Well, a times b, if we look at the previous video in the number theory playlist, then we can see that a times b is equal to, so the product of any two numbers is actually equal to the product of its GCD, of their GCD times, and the product of their GCD and their LCM. So it's a pretty interesting relationship. And we've represented each of these as variables, so we can just put it as x times y. Yeah. So we can rewrite this equation. We can rewrite this equation as a times b equals 63. A times b plus 63 can be written as xy. I'll put this in another color. xy plus 63 equals 20y. 20 times LCM will be 20y plus 12x. And then this can be written as, if we move all of these to this side, we get this. And then we can factorize this into x minus 20 times y minus 12. And then we have to get rid of the, so if we evaluate this, we get the same thing as this, but then plus 240. So we have to minus 240. So then if it's minus 240 on this side, we send it here, then it'll be plus 240. So 240 minus, or in simpler words, if we evaluate this, then we get this expression plus 240. So we've added 240 to this side, so we're going to add another 240 to this side to get this, which is just equal to 177. And how do we do this? So I think I'll make another video on some techniques, like focusing on these kind of factorizations and involving integers, because this is really important in a lot of math competitions. So how we would do this would be, so 177 has the factors, if I write it down, 1, 3, 59, and itself. So each of these must be a pair of numbers that multiply to this. So it can be 1 times, this can be 1 and this can be 177, this can be 3 and 59. So we rewrite the possibilities down. The only possibilities for a pair of numbers which multiply to 177 would be these. And also we can do -1 and -177 and so on, but then that will result in either one of at least one of x and y being negative, which cannot happen because a and b are positive integers, so the GCD and LCM must be positive as well. And before we look at all of these cases, we have to remind ourselves that x has to be smaller than y. So if we have these two conditions, then we can obviously see that if x minus 20 is equal to 59 and y minus 12 is equal to 3, then x will definitely be larger than y, and obviously for this case too. So we can just get rid of these by just observing. So we're left with these two cases. So we can try to evaluate it. So we have two cases. X minus 20 equals 1 and y minus 12 equals 177. Or the case x minus 20 equals 3 and y minus 12 equals 59. So if we evaluate these, we get that the values of x and y for this case will be 21 and 189. And so x equals 21 and y equals 189. And here x equals 23 and y equals 71. So here, so we can now check these two cases. So x is definitely smaller in both of these cases. And let's see if x divides y in both of these cases. So clearly, we know that 21 times 9 is equal to 189. So 21 divides 189. So we can check that this works. This solution works. But for this, we can see that 23 does not divide 71. So this will not be a possible solution. So the only possible values for x and y is 21 and 189. Yeah. So if we write, so therefore we know that x, which is GCD of a and b, is equal to 21. That equals sign. Yeah. And the LCM of a and b is equal to 189. So we want to use these pieces of information to find the possible values for a and b, number of ordered pairs of a and b. And an easy way to do this would be to first prime factorize these two numbers, as I said in the GCD and LCM video. So this is equal to 3 times 7. And this is equal to 3 cubed times 7. So we get that. Yes, so we have to find the possible values for a and b using these prime factorized forms. So how we do that is recall that the GCD is the minimum exponents of each prime factor. So here we can see that firstly the power of 7 is 1 in both of the GCD and LCM, which means that a and b both must have exactly 1/7 in its prime factorization, exactly 1/7, because its minimum and maximum exponent of 7 is 1. But then the minimum exponent of 3 is 1, because the GCD has only one power of 3, and the maximum exponent is 3, as the LCM has a 3 to the 3. So either a and b can be equal to 3 times 7 and 3 cubed times 7, or it can be equal to, their order flipped around. Because their maximum exponent, one must have a 3 to the 1 and one must have a 3 to the 3, so that the minimum exponent is 3, and the minimum exponent is 1, and the minimum exponent is 3 for the prime factor 3. So there are two possible ordered pairs for A and B that satisfies this relationship. So the answer, so there are two possible solutions, which means that the answer must be B. Yeah. So that's it. And this is a really nice problem. Like, I think this is a good problem to look at to gain a better understanding of the GCD and LCM, because it involves prime factorizing to find the GCD and LCM, like the basic skills, and also a utilization of this relationship. So yeah, hope you enjoyed this video, and yeah, take a look at some more AMC videos and number theory videos and other videos I made. And yeah, see you next time.